Let's go over a practice problem for this week's discussion quiz. So in question 1, it says, verify the function the square root of x satisfies the conditions of the mean value theorem on the interval from 0 to 9. Once we do that, I'd like to find all numbers c in this interval that satisfy the conclusion of the mean value theorem. Starting with the conditions, we need to know two things about the function f of x, that it's continuous on this interval and that it is differentiable within this interval. Both of these things are true, so I'm going to state that. I'll say that f of x equaling the square root of x, a root function, is continuous on its domain, which for the square root of x is from 0 to infinity. Therefore, f of x is continuous on 0 to 9. Next, is this function differentiable with inside of this interval? The answer to this is also yes. I'll say as f of x is equal to also x to the 1/2 power, the derivative f prime of x is equal to 1/2 x to the negative 1/2. This is the same thing as 1 divided by 2 times the square root of x. So this function f of x, f prime of x, is defined on the interval from 0 to 9, not including 0 or 9. And so f of x is differentiable on 0 to 9. So that's just a fancy way to say you can take the derivative of the function, and any number that you take within this interval, you can plug into this function here. Notice that we're not including 0 because this is a parenthesis. In fact, 0 would be the only number that causes an issue. These are the two conditions of the mean value theorem. So I'm now going to go on to say, by the mean value theorem, there is a c, so number c, in the interval from 0 to 9, such that f prime of c is equal to, in this case, it's f of 9 minus f of 0 all over 9 minus 0. This is the conclusion of the mean value theorem. You can find a place where the derivative at that number is equal to the slope, the average rate of change between the endpoints of this interval. I'm going to do this computation on the next slide so we can solve for the value of c. Basically, I'm going to take c, put it into this thing here for the derivative, compute this side of the equation, and solve for c. Here I just simply copied down what was on the previous slide. 1, the derivative of the function, and then the conclusion of the mean value theorem. I'm going to take c and put it into this formula here. The original function was the square root of x, so I'm going to put all of this information using that formula. That is, we have that 1 over 2 times the square root of c is equal to the square root of 9 minus the square root of 0 all over 9 minus 0. On the left, we have 1 divided by 2, the square root of c. On the right, we have, well, the square root of 9 is 3, square root of 0 is 0, and we're dividing by 9. This simplifies as 1 over 2 root c is equal to 3 over 9, or really 1 over 2 root c is equal to, in this case, a third. Continuing my work over here, I'm going to multiply 3 to this side of the equation and actually just multiply the square root of c to this other side. This will give me 3 over 2 on this side, and then the square root of c on this side. So that is, we have 3 over 2 is equal to the square root of c. If you're looking to solve for c, we can simply square both sides of this equation. On the left, we'll have 9/4. On the right, if you square the square root, it cancels to just give you c. And here, this is the value for c, for which this equation is true. This number, 9/4, should be within the interval from 0 to 9. And it is. 9/4 is 2.25. That's greater than 0, and it's less than 9. And that's the answer to this problem.